All right, let's try this one again. So we have the mean of a set of numbers is 5/9, and that's the mean. And the difference between the largest and the smallest number is 1/2, which also happens to be one of the numbers. Well, right now I know that 1/2 is one of my numbers. So I'm looking for the smallest of the numbers, and 1/2 is in between the two numbers. Now, right away, I can write an equation. And the equation is the difference between the smallest and the biggest. So let's call this y. Let's call this x. You'll see why I switched the orders in a second. And so I have x minus y is equal to 1/2. Great. Then, the other key is the whole idea of the mean of the three numbers being 5/9. So we have three numbers all averaging 5/9, which is equal to 15/9. I know this is not reduced. I know this is equal to 10/6, which is also equal to 5/3. And I want to keep them in different forms right now so that I can pull upon whatever one is the most likely to be useful. Really the 10/6, because I know I have halves I have to deal with. So 10/6 is the form of the sum that I'm really going to be after here. Well, I know the sum of all three numbers is 10/6. Well, but half of them are already accounted for. So that's 3/6. So that means I have a total of 7/6 remaining. So that means x plus y has to equal 7/6. Oh my goodness. I have a system of equations. And not only do I have a system of equations, I have a system of equations that has opposites right here. So let's go ahead and add them straight down. So I end up with x plus x, which is 2x. Negative y plus y is 0. And over here, over here, I end up with, so that's 3/6. So I do get 10/6. So then, divide by 2, which is the same as multiplying by 1/2. So I get 10/12, which reduces down to 5/6. Now that's my x value. My x value is my larger of the two numbers. Well, if I have 5/6 and 5/6 plus something, I don't know what that something is equal to 7/6, then I know I'm missing 2/6. Well, 2/6 is just a fancy way of saying 1/3. So my other number is 1/3. All right, number 9 was also requested. So number 9, I used a calculator. I will be very honest with you. I went to the y equals screen. I said y equals x to the third. And so I got a list of cubes. So 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, 5 cubed is 125, 6 cubed is the 216. And so 7 cubed is bigger than 216. But right away I know that if I have 4 numbers, right? 1 plus 8 plus 27 plus 64 is not going to be 125. So I can skip that right away. I know this 1 is not used. 8 plus 8 plus 27 plus 64 plus 125 is 216. Oh my goodness, it really was that simple. So I know 6 has to be my z value. And so it asks for my z. This happens to be w. Here's w, x, y, and Oh, sorry. So it's 27 plus 64 plus, sorry, my bad. So if I go 8 plus 27 plus 64, it does not equal 125. Thank you. So that 8 doesn't, so 2 doesn't work. So if I go 27 plus 64 plus 125, that is my 216. It's late. I wanted to go home. I'm getting ahead of myself. I'm sorry. So we have our W, X, Y, and here's my Z. Sorry about that. So the answer is 6. Finally, the last one, the big bag of marbles. Woohoo! This is just another testament to why I love equations and ratios. So the first thing I notice is red and white marbles are equal. So I said R is equal to W. Simple enough. And then it says 5 times as many green marbles as blue marbles. So that means 5 times blue is equal to green. And then it gives us the key to this problem. 35% are red marbles. So I said red, white, blue, and green. So if I have 35% red, that means I must also have 35% white. So that means I have a remaining 30% because that's 70%, right? So I know that green and blue combined is 30%. Obviously, I'm trying to think of the best way to explain this right now. And so, what number times 5 is 30? Or sorry, what number plus 5 is 30? Well, it's 25, right? And so I know, and this is a poor job of explaining, that I have 5 times 5, which is 25. 5 plus 5 is 30, kind of like a factoring problem. And so if I had 100 total marbles, I'd have 35, 35, 5, and 5. Well, let's reduce that, right? What is the fewest possible? Well, what number goes into all 5 of these? Well, thank you. Well, we know that 5 goes into all of them. So if I reduce all of these by 5, I get 7, 7, 1, and 5. And I want to know fewest possible number of green marbles, which is 5. And that's how I did it.